Welcome. So in this lesson, we're going to be talking about the discriminant, which corresponds to exercise 3I of your textbook. So once we're finished going through these notes, you're going to begin exercise 3I. So what is the discriminant? Here it is. The discriminant is equal to b squared minus 4ac. Let's now break down what the discriminant is. So first things first, you've got this funny looking triangle here. So the discriminant is denoted by the symbol delta. So this is a Greek letter. This is the Greek letter delta, and it's what we use to represent what the discriminant is. So we say the discriminant is equal to this, and we use delta to represent our discriminant there. Now, where does the discriminant come from? If you think back to your quadratic formula, so remember the quadratic formula is used to find our x-intercepts, and it is this. It is negative b plus or minus the square root of b squared minus 4ac over 2a. Hopefully you can see there, underneath the square root, we have b squared minus 4ac, which is the same as our discriminant. So where we get the discriminant from is from our quadratic formula. It's just what's underneath the square root. Now, what's the point of that? What's the point of isolating the discriminant and giving it a fancy name? Here we are. The discriminant can be used to determine the number of solutions of a quadratic equation. So it can use to determine the number of solutions of a quadratic equation. What I'll get you to do, where it says solutions, this is going to be the same thing as x-intercepts. So we can figure out the number of x-intercepts of a quadratic equation. So let's now look at the three options we'll have before us. If our discriminant is greater than 0, it means we're going to have two solutions. And remember, a solution is just an x-intercept. So it means we will have two x-intercepts. So when our discriminant is greater than 0, we'll have two x-intercepts. If our discriminant is equal to 0, it will have one solution. So let's now look at this. As you can see, here is our quadratic, and it only touches the x-axis once. So it has one solution, one x-intercept. And then finally, we have our discriminant is less than 0. And this means no real solutions. And as you can see here, it doesn't touch the x-axis at all. It has no real solutions. It has no x-intercepts. So that is the basics of how the discriminant works. It's where it's come from. It's the letter we use to denote it. In the next part of this lesson, we'll go through some more examples here. I'll see you then.